We are now in rational equations. A rational equation is an equation that has a rational expression for one or more terms. So that's the definition. And then we need to know what are rational expressions. So that's similar to fractions, like for example, 1/2. 1/2 would be a fraction, but it becomes a rational expression if you're going to say 1 over 2x, or you can say x over 2. That would be rational expression. And then in this equation also, we should know how to find the LCD, which is the least common denominator. This is exactly the same thing as the LCD from a regular fraction when you're trying to add or subtract fractions. Okay, so let's have an example. So thinking about a fraction 3 over 4. That's a fraction. It becomes a rational expression if I put x here at the bottom. And then I will add that to a whole number equal to, let's say, 1/2. So this is an example, a simple example for a rational equation. So this is still solving for x. Okay, so LCD here, looking at for x as the first denominator on the first term. On the second term, it's a whole number 3. The bottom should always be 1. Any whole number has a denominator of 1. And then on the right side of the equation, you have a 2 there. So the LCD would be 4x. So that LCD actually is going to be used to eliminate the bottom term. This is just like eliminating the denominators. So I'll just multiply 4x to all of them. So I will do multiplying 4x here. I'll do the same thing here, 4x. It's like multiplying 4x to the whole equation. And then I will just calculate. So 4x and the 4x at the bottom can be cancelled out. What's left is 3 plus 3 times 4x is 12x equals 4 and 2 can be cancelled out. So you'll be left with 2 on the top. The answer would be 2x. And now you can combine like terms. So I'll do 12x here, moving 2x from right to left, combining like terms, becomes a minus 2x. And then the 3 from the left can be moved to the right side, becomes a negative 3. Again, you can always do elimination by adding or subtracting a number to left or the right side. For example, 3, I have to eliminate 3. I have to subtract 3 on the left and subtract right to the right minus 3 also, or a negative 3. So you can do that and it will give you the same result. So adding or subtracting numbers. So here 12x minus 2x, that would mean 10x equals negative 3. And then divide this by 10 to get our x. Then our answer would be a fraction. It's negative 3 over 10. Now, this is not exact. You cannot reduce that. So that would be your answer in the solution set. But take note that this is a rational equation. See if when you plug that in to the original expression, it's still defined. So obviously when you plug that into x, it's still defined. So the answer is -3/10. Now, when will be the time when um, your equation is undefined or your expression is undefined? When x is equal to 0. So when you plug that in there for the equation, then it becomes a 0 for x there at the bottom. So 4 times 0, that becomes 0 at the bottom for 4x. And then that would become undefined. So your final answer at that value, that would be empty set. So if that is the case. But in this case, our answer is -3/10. Okay, so next example. So for this example, you have 3 as a denominator of the first rational expression. On the second rational expression, you have x minus 1. So therefore, my LCD here would be 3 times x minus 1. So that's the LCD. I have to multiply that LCD to the first term and the second term and on the right side, which is the third term. So I will say 3x minus 1 over 3 and multiplying the LCD, which is 3 times x minus 1. Then just copy the second rational expression and then multiply this by 3 times x minus 1, and on the right side of the equation you multiply also the LCD, which is 3 times x minus 1. Okay, and then you can cancel something. I'll cancel the 3 here, and then my answer would be equal to just erase the equal sign here because we have one equal sign only. That's an equation. So our answer would be the result of multiplying 3x minus 1 times x minus 1. So it gives us 3x squared. So this is what I did, multiplying that and multiplying the 3x times a -1, that's a minus 3x, and then multiplying -1 times your x is minus x. -1 times -1, it's a +1. And then the next one is canceling x minus 1. So you have x minus 1 on the top and at the bottom, so you can cancel that out. The expression left now, it's minus 6x equals. Okay, so I'll multiply x times 3. That's actually 3x times your x would be 3x squared. And then x times 3 times -1, it's a negative 3x. So we're just using distributive property. And then 3x squared appears on the left and appears on the right. So either you move this to the left or to the right side and changes the sign, it becomes a 0. So this can be canceled out. And what else can be canceled out? -3x is the same as -3x on the other side. That can be canceled out. So what's left would be negative 7x. That would be negative x plus or minus 6x. That would be negative 7x, combining like term. And then I have to move my 1 to the right side. So positive becomes a negative 1. And then I have to divide negative 7 on both sides. So x now is equal to a positive 1 over 7. And I have to check if that is undefined. Look at the top. I have x minus 1 on the second rational expression. So when I plug that in, still defined. So that would mean that would be the answer. So always check your answer if that is defined or not. You can plug that in and it becomes undefined. So that's the answer. 1 over 7. Okay, now let's go to the word problem. It's just an application for rational equation. Okay, so here's the formula. So if you remember the distance formula, d is equal to rt. So that's exactly the one. So it's over here. So the distance goes to the a, the amount of work is equal to rate times time. You know, rate. So when you have rate, it's actually like speed, and t is time. So that would be number of hours, number of minutes, number of seconds. Okay, so here's the example for the applied problem. I'll give you a chance to read and understand the problem. From what we did in the previous sections, we're trying to analyze word problems by reading and understanding it, and then if you can actually sketch or draw something to visualize the problem, the better. And then you are going to write or formulate the equation. So here's the first step. It's reading the problem and understanding the problem. So this is working together problem. Step two is actually looking at the two printers. So the other one is fast, the other one is slow. So you will get this 2 over x by having the formula um, rate times time. So where's that is equal to the amount of the job you're doing. So that's your A. So again, A is equal to R times T. So multiplying that, it gives you 2 over x is equal to 1 over x. And here's our equation. So looking at this equation, this is coming from what we've shown you a while ago on the faster printer, and the slower printer has 1 over x. So, and then adding that, it gives you one whole job. It's right there. So because this is the first expression or rational expression is the amount of job done by the fast printer, and the second one is the amount of job done by the slower printer, equal to 1. It's always equal to 1. And then from there, you can actually solve for your x. So looking at this, the LCD here is LCD, you have x here, and then you have x, and then the bottom of your right side of the equation, it's a 1 because that's a whole number 1. So therefore, the LCD here is just x. So you can multiply the whole equation by x. So multiplying x here, multiplying x here, multiplying x here, and then x will be cancelled out on the first term. So what's left would be just 2 plus your x would be cancelled out on the second term, be 1 is equal to x. So therefore, you'll get 2 plus 1, that would be 3, and you will get x is equal to 3. Let's write that out at the bottom. X is equal to 3. And this is in terms of actually number of hours, because that would be the question asked. So you put the unit hours, and that would be your answer. So that's for the fast printer, right? And then for the slower printer, it's 2 times x. So you will get 2 times 3, that would be 6. 6 hours for the slow printer. So 6 hours for the slow printer. Okay, so fast printer, and then this is the slow printer here. Okay, so you have two answers, 3 hours, and then that's for the fast printer, and then the second one is 6 hours for the slow printer.